First, write the values that make the denominator 0, then solve the equation. Remember that because we're solving a rational equation and we have a variable in the denominator, we have to check for extraneous solutions. We want to make sure that we never let the denominator equal 0. So in this case, I have an x, 2x, and a 5 in the denominator. So I need to make sure, that never ends up equaling 0. So if I, like I said, x equals 0, 2x equals 0, those both have the same solution. So x equals 0. So that's any value that would cause the denominator to be 0, and I would disallow that solution. Okay, so here I'm solving a rational equation. One way to start is to go ahead and just clear all your fractions. Because I have an equation, I can multiply both sides by anything I want. If you multiply by the least common denominator, you can wipe out your fractions. So between the x, the 2x, and the 5, and again, that's 4 over 1, 10x is my least common denominator. So again, I'm going to multiply both sides by 10x. And then I'll reduce. So I'm going to multiply every term by 10x. So in the first one, the x's will cancel, and I'm left with 8 times 10, so I've got 80. And then I have 4 times 10x, so that'll give me 40x. On the right-hand side, 2x will go into, the 2 will cancel into 10 5 times, the x's cancel, so that will give me 5. And then lastly, 5 will go into 10 twice. And then 9 times 2x will give me 18x. So now I have an equation, but no more fractions. Okay, so solving this, you guys are all good at this now. I'm going to bring the 18x over, and I'll get 22x, and I'll also bring the 80 over to the right-hand side. I get a negative 75. Now dividing both sides by the 22, we have x equals negative 75 over 22. And I may be done right here. My answer is a fraction, so I want to check to see whether or not it'll reduce. It does not. So like I said, we're pretty much done. The only other thing we have to make sure of is that we're not dividing by 0. But again, we already know that the only bad solutions would be x equals 0. Question number 9. We're asked to solve this equation. Now we're not told what type of an equation it is, and so you got to look at it a little bit to decide what method you want to use. If you're not sure where to start, at least start simplifying it. Like I said, we know we can always do that. So in this case here, foiling on the right-hand side and multiplying that out, I'll get 3x squared plus 3x minus 7x minus 7. And I can pretty much tell right now it's going to be a quadratic equation, and I have a couple different methods for solving those. But I'm going to go ahead and just keep simplifying for now. Again, on the right-hand side, my like terms, let's say I get 3x squared, this will give me a minus 4x, and then minus 7. So with quadratic equations, we have a number of different methods, but majority of them we're probably going to solve using either factoring or the quadratic formula. And so for both of those, I have to have it in the standard form. So let me go ahead and bring the 2 and the 10x over. So subtracting 2 and adding the 10x to both sides is going to give us 3x squared plus 6x minus 9 equals 0. Okay, so like I said, from here you have a choice of several methods. I prefer factoring, so I'll always try factoring first. If I can't factor it, 30 seconds, then I'll probably move on to the quadratic formula. One thing I notice here with factoring, I do have a greatest common factor, so I'm going to take out the 3, and that gives me x squared plus 2x minus 3 is equal to 0. And then I'm left with a pretty nice trinomial. Okay, x and x, and then 3 has to be a 1 and 3. Since it's a negative 3, 1 is positive, 1 is negative. I'm going to have a negative 1 and a plus 3. When I FOIL that out, it'll give me my 2x in the middle. Okay, now we set each of these equal to 0 and solve them. I'm sure most of you can probably go ahead and just set this equal to 0 in your head and come up with x equals a 1 and x equals a negative 3. And in which case, I'd want you to just solve them in your head. You don't need to show me any work. If you're not certain about what we did, like I said, I'll come on over here and show you. We just take each one of these and set it equal to 0. So 3 equals 0. We can't let 3 equal 0. We have x minus 1 equals 0, and then x plus 3 equals 0. And then we solve each of these. So adding 1 to both sides, x is a 1. Oops, sorry, x equals a 1. And then subtracting 3 from both sides here, we get x equals a negative 3. But again, ideally, you will kind of do these in your head when they get to be linear factors like this one here. So question number 11, we're asked to solve. So for this one here, like I said, if you're not sure what to do, you can go ahead and just start simplifying, multiplying things out. But it's good to sort of look at it a little bit. This one, hopefully you'll recognize it kind of has the form of something squared equals a number. And so the square root property is a really good choice for solving this one. On the test, I don't usually dictate the method. I'll let you decide what method you want to use. So like I said, this one here, a lot less work using the square root property. And again, the only way it works is if you cannot have a variable on the right-hand side. So you need to have something with your variable squared equals a number. So if you can get in that form, square root property is perfect. So the square root property says if you have x squared is equal to some number b, then x is going to be equal to plus or minus whatever the square root of b is. So for this case over here, again, I have my left-hand side. Think of all that as being my u squared or my x squared. So 11x minus 12 is going to be equal to plus or minus whatever the square root of 20 is. Now looking just here at on the left-hand side, 11x minus 12, that's linear. To finish solving it, I'll add 12 divided by the 11. Don't forget that over on the right, you do have to simplify this radical. So 20, break that down as 4 and 5. So 11x minus 12 is equal to plus or minus 2 squared of 5. And then I will bring the 12 over, so I'm adding 12 to both sides. And again, since these are not like terms, I cannot combine the 12 and the 2 squared of 5. So I'm going to write it as 12 plus or minus 2 squared of 5. And then dividing by the 11. So I get 12 plus or minus 2 squared of 5 all over 11. Now I'm happy for you to leave your answer written just like this. You may have seen it written as two different solutions. So 12 plus 2 squared of 5 over 11, and then the other one would be 12 minus 2 squared of 5 over 11. So just if you're looking at multiple choice, you may have to find the two separate solutions. If you are inputting it into my math lab, they may ask you for two separate solutions. For me on the test, like I said, if it's a free response question, you can write it for me either way. I would stop right here. Number 15, we're asked to solve by completing the square. So in this one here, I do dictate the method. So this is the only method that's going to get you full credit. Okay. So when we were working on by completing the square, remember that key step is we try to force the left-hand side to be a perfect square, like we did a couple problems ago, and that way we can finish it using the square root property. So the first two steps, we need to make sure that the leading coefficient is a 1. So I need a leading coefficient is equal to a 1. And then also I want to go ahead and isolate my variables on the left. And I'm going to put my constant term over on the other side. So I'm going to put my variables on the left-hand side. So over here I will leave my x squared and my 4x on the left. And then bringing the 40 over, I will subtract 40 from both sides. Question number 15, we're asked to solve by completing the square. So for this one here, I did specify a method. You're going to have to use this method in order to receive credit. So recall that by when we solve by completing the square, the idea was to get it into the form of something squared is equal to a number, and then we're going to finish off using the square root property. But first we have to get it in that form. Okay. So for my first two steps are going to be getting a leading coefficient of a 1. And then also I'm going to isolate my variables on the left-hand side. So my leading coefficient equals a 1, and then the variables on the left-hand side. Okay, so I already have a leading coefficient of 1. So I'm going to keep my x squared and my 4x on the left, and then I want to move the 40 over. So I'll subtract 40 from both sides. And I'm going to leave a blank there because usually I won't rewrite it. I just put in the missing number. So then my next step is, okay, so this is the key step. I need to go ahead and figure out what is half of that middle number, or half the coefficient on the b, and then I have to square that. So it's going to be half b squared. That's what I want to add to each side to make it a perfect square. So in this case here, half of 4 is 2, and 2 squared is 4. So I will add 4 to both sides. Make sure you always do everything to both sides. Okay, so now the left-hand side is going to factor into a perfect square trinomial. That's why we chose the 4. So it becomes x plus 2 squared. So again, it's going to be half of that middle one squared. And on the right-hand side, we have negative 36. Okay, so the rest of this, like I said, we finished it using the square root property. So x plus 2 is going to be equal to plus or minus the square root of a negative 36. I do want to go ahead and simplify or reduce my radical. So the square root of negative 36 is 6i. So plus or minus 6i. And now to finish solving this for x, I just need to subtract 2 from both sides. So x is equal to a negative 2 plus or minus 6i. These are not like terms, so I can stop right here. Again, that can be written as two separate solutions. So negative 2 plus 6i and negative 2 minus 6i. I'm also fine with you leaving your answers written kind of, it's still two solutions, but written combined like this. One little side note I want to make here is, when do we keep going further? So if I happen to have x, let's say, suppose I had x plus 2 is equal to plus or minus a 6, not 6i, but just a 6. Well, then I can keep going. So when I bring the 2 over, so I have x is equal to a negative 2 plus or minus 6. These are like terms, I can combine them. So in this case, I would have to keep going. Negative 2 plus 6 and negative 2 minus 6. And I would end up with 4 and negative 8 for my solutions. So again, it really makes a difference as to whether or not these are like terms. All right, number 24, solve. Okay, so here I have another equation that happens to involve fractions. So again, if I look at all terms, both sides of the equation, what's my least common denominator? In this case, it is 12. So multiplying through by a 12 will wipe out all my fractions. Don't forget to distribute. So everybody gets multiplied by a 12. All right, so my first term, the 12's cancel, and I'm left with x squared. Then I have 12 times x, so plus 12x. And the last one, the 12's cancel, so plus 13. And then 0 times 12 will just give me a 0. So now I have a quadratic equation. And usually, like I said, what I'll do is I'll go ahead and I'll try to factor it first. And if that doesn't work, I use another method. So when I try to factor this, I've got x and x. The only options for 13 will be 1 and 13. And in order to get a 12 out of that, if I had a plus 13 and a minus 1, that would work. But then if I FOIL it, that is a negative 13. And I have a positive 13. So factoring's not going to work. I need to use the quadratic formula. So again, the quadratic formula states if you have ax squared plus bx plus c equal to 0, then the solutions are given by x equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. You do need to have that quadratic formula memorized. My values for a, b, and c, again, they're going to be the coefficients from my quadratic equation. So in this particular example up here, I've got a is going to be equal to 1, b is going to be equal to 12, and c is equal to 13. And that's what I'll plug into my formula for a, b, and c. So x is equal to a negative b, negative 12, plus or minus the square root of, I have b squared, so 12 squared, minus 4 times a times c. So 4 times 1 times 13. And then all over 2 times 1. Okay. Usually the mistakes I see students make with the quadratic formula involve signs. So just be extra careful with your signs when you're using the quadratic formula. So I have a negative 12 plus or minus. Now I have to completely simplify underneath the radical before I can reduce it. So I got 12 squared is 144. And then 4 times 1 times 13 is 52. So that's going to be minus 52. And then all over 2. 140, again, I'm still working underneath the radical. So 144 minus 52 is going to give me 92. And then, like I said, here I may be done. It all depends on, simplifying it. So the first thing I need to do is see if my radical root will reduce and break down. If it doesn't, we're finished right here. If it will reduce, then I need to reduce it. Then I look for like terms, and then I look for reducing the fraction. Okay, so 92 is 4 times 23. And so I have a negative 12 plus or minus, the square root of 4 is 2, so I get 2 square root of 23 all over 2. Now I don't have any like terms, so I cannot add them, the 12 and the 2 squared root of 23, but I can simplify my fraction. So one way of doing it is to factor out a 2, since I can take out a 2 from, what I'm looking at is I'm taking out a 2 from here, here, and here. So if I factor out the 2, then I can cancel it. Another thing is you can just kind of like mentally factor it out and just say, okay, I'm going to cancel a 2 from each term. So I'm going to cancel a 2 here, giving me a negative 6. Cancel a 2 here with a 1. Cancel the 2 here and a 1. And so that leaves me with a negative 6 plus or minus the square root of 23 all over 1. So negative 6 plus or minus square root of 23. Number 25, solve the problem. You must write and use an algebraic equation when you are solving word problems for me. It's an algebra class, so no credit for just plugging numbers into your calculator and guessing. You got to write that equation. Okay, so for this one here, let me go ahead and we'll read through it together and then figure out how to tackle it. So the formula n equals 4x squared plus 5x plus 3 represents the number of households, n in thousands, in a certain city that have a computer x years after 1990. According to the formula, in what year were there 87,000 households with computers in this city? So when we are given a function, like I said, I know this equation here is going to be used in some way in setting up my equation that I need to solve this word problem. But I need to understand what the variables are. So take a moment to kind of, just step aside and look at that. So what does n represent? So n is the number of households in thousands. So number of households, that have a computer. So number of households with a computer. And it's really important that you make note that it's in thousands. So if n is equal to 3, that's 3,000, not just 3 households. And then my other variable I have is x. And so x is measuring the number of years since 1990. So number of years since 1990. Okay, so you tell me the number of years since 1990, plug it into n, and it'll spit out the number of households in thousands that had a computer. Right, and like I said, don't underestimate taking the time to, understand what your variables represent. It really helps us figure out the equation, right, what the question is. So now we're asked is in what year? So I'm asking you for what, x or for n? Well, x deals with years, so I'm saying, hey, solve for x or find x. And then when there were 87,000 households with computers. So that's telling you n is equal to 87. So I want you to solve for x when n equals an 87. So my equation is going to be 87 equals 4x squared plus 5x plus 3. And this is very typical of solving applications where you're given a function or a formula to use. Okay, so now I've got this equation. So great, I got to solve it. It's a quadratic equation. We have lots of methods of solving quadratic equations. So again, I'm going to think about using, factoring. If not, I'm going to move quickly onto the quadratic formula. First, I got to get into standard form. So subtracting my 87 from both sides. Now I'm going to have 4x squared plus 5x minus 84 is equal to 0. And again, play around a little bit with this factoring. I don't have a common factor, but like I said, it's either going to be 2x and 2x or 4x and 1x. I've got a big number here, the 84, so like I said, I've done a lot of factoring, so that tells me I'm probably going to want to try to break it up using bigger numbers. So 84, again, there's a number of different options, so you play around with some bit and see what numbers might work. So 4 and 21, and again, when I'm foiling this out, this will give me 21, and that'll give me 16, and that's how I get my 5x in there. So figuring out my sign, I know one is positive, one is negative. So let's see if I got a negative 16 and a positive 21, that'll give me my positive 5x. And so setting both of these equal to 0 and solving them, so 4x plus 21 equals 0, x minus 4 equals 0, and so x is a negative 21 fourths, or x is equal to 4. And again, I think you could have probably just done that step there in your head and come up with the two solutions. Okay, so now I'm ready to answer the question. I know x is equal to 4. This one makes no sense because x is the number of years since 1990. We're not going to go back in time. So this is the only viable solution, this one here. So in 1990, that's my starting time. That's when x is equal to 0. So 4 years later is going to be 1994. So again, I take my 1990, whatever year that is, plus my 4. And so 1994. That's the year that we will have 87,000 households with computers. Number 31, solve. In this case here, we are given a rational equation. So I want to solve a rational equation, think IRS. First thing I need to do is isolate the radical. And if I happen to have more than one radical, I'm going to isolate one of the radicals. The next thing I'm going to do is I'm going to raise each side to a power. If it's the square root, I'm going to raise it to the second power. If it's a cube root, raise it to the third power. Now, raising each side to a power does cause me some issues at times. So I'm going to have to come back and deal with that. And then the last thing I'm going to do is solve for what's left. Now, sometimes once you get to this point here, you raise each side to a power, you may still have a radical. Okay, so like if my original problem, I had a couple radicals, I raise it to a power, I may still be left with a radical. Then I kind of just go back up to the beginning and repeat. That's not going to be the type on your test. So on your test, you're going to have just one simple radical. Okay, so I'm going to isolate the radical, raise each side to a power, then I'm going to solve for what's left. Whenever I use my power rule, though, I'm going to have to go ahead and check my solution. Must check for solutions. When I square each side, I introduce additional solutions. So they work for the equation once I square it, but they didn't work in the original. Okay, so let's go ahead and tackle this one here. So I've got the square root of 2x over here on the left, so I'm going to leave it there. I'm going to move the 8 over. So I've got to isolate the radical. So square root of 2x is equal to x minus 4. Now I need to go ahead and raise each side to a power. Since it's a square root, I'm going to square it. Because now I have the square root squared, those undo each other. I'm just get 2x on the left-hand side. And then how about over on the right-hand side? And don't forget to FOIL. You've got to FOIL that out. Okay, if you know the formula, that's great. You can use the formula. Just make sure that you're doing it correctly. So if I FOIL it, I get x squared minus 4x plus 16. And so we have 2x is equal to x squared minus 8x plus 16. This is the quadratic equation. Now I have options. I'm going to try to factor it. If not, I'll go on to the quadratic formula. And again, before we can do that, we do have to bring the 2x over. So we have x squared minus 10x plus 16 is equal to 0. And this one will factor, I can see it right away, x minus 2 and x minus 8. Again, foiling to check this. So x equals 2 and x equals a positive 8. These are my two potential solutions. But because I use that power rule from back here, I need to go ahead and make sure that they work. When you're checking them, make sure that you check them into the original equation. Once you square them, that's what caused the problem. So you've got to plug them in before you square them. So let me try the 2 first. So I've got the square root of 2 times 2 plus 8. The question is, does that equal 2 plus 4? So square root of 2 plus 2, I get the square root of 4. So I get 2 plus 8 is, oh no, that is not equal to 6. So that means x cannot be a 2. That is not a solution. Let me try 8. So the square root of 2 times 8 plus 8. Does that equal 8 plus 4? So square root of, I got 2 times 8 is 16, so the square root is 16, so I've got 4 plus 8. Does that, oh yeah, 12 is going to be equal to 12, definitely. So that means x equals 8 is a solution, but then x does not equal 2. So we got only one solution this time. We had 2 potential solutions, but only one of them worked. X equals 2 is said to be an extraneous solution. Make sure that you're checking for these on your exam.